they might end up thinking that they have the right data when they don't because someone else has changed it. All of it is going to filter into the Mongo database, which is going to relay out these change streams, which are going to connect to these socket services, and those socket services are going to publish all of the data changes back to the clients. So what that ends up doing is everything gets filtered through MongoDB, and it acts as your source of truth, and it makes sure that everybody has all of the latest data changes. By the way, stop me if any of this stuff is like, and I need to explain anything, because it's going to get like really technical really fast. In order to spin all this stuff up for the demo, I'm going to use Docker, specifically just Docker Compose, to make it pretty simple. If you haven't used that before, you basically define these different services. A service is basically just an application. The first one here is going to be our front end, followed by our back end. This is our socket service. We're going to be using a Redis cache to store some stateful socket information. I'll explain that later. We're going to use a Mongo replica set, which I'll also explain in just a second. And then finally, I added Mongo Express here in case like y'all go home and you want to spin this up. This is a working demo. It is available on my GitHub. And if you have Docker installed, you run this one command, and it should just automatically be working for you. And Mongo Express is this guy. It lets you peek into the Mongo database just to make sure that everything's working. It's like an easier way of working with Mongo, especially if you're new to it. Okay, so to enable change streams, you either have to be using a replica set or a sharded cluster. In this case, I'm going to be using a replica set. If you were using a tool like Kubernetes, you would do this with a headless service and a stateful set. But Docker is more like academic and abstract. They don't have those concepts. So in this case, you actually have to define each of your services manually. So in our Mongo replica set, we're going to have 3 instances: Mongo 1, Mongo 2, and Mongo 3. So Mongo 1, the first thing we're going to find here is what image we're using. We're using the Mongo 4 image. That's super important because Mongo introduced change streams in 3.6, but the change stream was only on collections. So you had to listen to specific collections for changes in your data. In 4.0, they introduced change streams on entire databases as well as entire deployments. In this case, my tutorial example is just going to be on databases, but it's super crucial that you're using 4.0. The command that's normally run is MongoD, but we need to add a flag, so we're overriding it here, and the flag we're adding is the RepleSet flag. That's part of the way that the Mongo instances find each other and know that they're part of the same replica set. And this can be anything arbitrary, so I just call it replica set. This is important, the volume that we're using. Normally you would, what's up? Go, am I talking?
Yeah, talking just a little bit.
Okay.
Talk a little bit.
Yeah. So normally you'd use a config in Kubernetes or Docker, but when you're not in Docker Swarm, it doesn't support configs. So in this case, I'm just mounting the volume to this specific directory, Docker entry point init db.d, and everything that's inside of that directory, whatever JavaScript scripts you have in there, Mongo is going to run it the first time it spins up. That's something really important to remember. So if you're working with an existing Mongo instance, whatever you put in there is not going to run. It needs to be the first time you actually spin up the Mongo instance. Otherwise, if you're working with an existing Mongo replica set, you're going to have to get into the Mongo shell and run that script. And then for the most part, Mongo 1, that's our primary, so it has that extra stuff in there, but the rest of them, they're all doing the same kind of thing, using the same image, flag, and all that stuff. So the script that initializes the replica set looks like this guy. The important thing here is this command, rs.initiate. What you're going to pass into this Mongo function is an object that essentially says what is the name of the replica set, as well as what members you want to add to it, or nodes. In this case, we have a 3-node replica set, And so we are going to add Mongo 1, 2, and 3 here. They're all using the default port 27017. And then these IDs here are totally arbitrary. They can be whatever you want. They just have to be different. Yeah.
Is what you're doing with the rest of this example dependent upon the Mongo configuration?
Yeah. Like it has to be configured as a replica set.
But it doesn't have to have 3 or...
Oh, no. So in order to get a replica set going, you just need 2.
Yeah.
A primary and a secondary. I'm just kind of arbitrarily choosing 3. You could have 20.
You said change streams were released in version 4.0 or one of those versions.
3.6 was on collections. 4.0 is on databases and entire deployments.
When you say deployments, do you mean something like adding a new node to the cluster, for example, or auto scaling? What does
it essentially means every single database that you add within the Mongo cluster.
Okay, gotcha.
So like looking here at Mongo Express, I only have one database added here, the app database. But if I added more databases, it would just listen to all of them. The only databases it won't listen to are the ones that are built into Mongo, which is the admin, config, and local databases. You can't get change streams off that, although I don't really know why you'd want to. All right, and then basically what this guy's doing at the bottom is it runs the rs initiate. If the other Mongo instances haven't spun up yet, it's going to fail. And then it's just going to sleep for 1,000 milliseconds, 1 second, and then try again. So as the different instances are popping up, it's going to fail, fail, fail. Once they're all up, it should succeed, and then it'll be complete. All right, so that's what you need to do just to get things started. So now this guy is the WebSocket service. The first thing we need to do here is connect to the database. This is fairly straightforward. We've got a Mongo client here. It runs the connect command. It connects to this URL. If you want to know what that URL looks like, it is in this config file. This is the type of URL that you use to connect to a replica set. You've got the MongoDB protocol, a comma delineated list of host names to your different Mongo instances. In this case, we have 1, 2, 3. And then we need to add this query parameter that is the name of the replica set, which in this case is app replica set from before. This use new URL parser, honestly, I just added that in there to get rid of a warning. I didn't see much of a difference, but it's being deprecated, so it's there. It is a promise, so if it resolves correctly, it'll resolve our connection to the database. The second thing we do here is set up the actual WebSocket service, or server, I mean. The first thing we're going to do is take our SocketIO web server, which is this IO guy, which is defined up here. All we had to do is require it and pass in an HTTP server. And by the way, if you don't need to use the HTTP server, you can just pass in a port number, like 80 or whatever, and it'll do it for you. In this case, I was actually kind of grabbing a lot of code from like when I actually did this for my company. So I just left it the way it is there because we had a single route for health checks. But yeah, it's not actually necessary. But the first thing we do here is we connect it to Redis. So what's going on here is that, let's say I have one SocketIO web server, and it runs out of capacity, and I need to scale up a second one to handle all of the traffic. It's not like a regular HTTP request where it's stateless, like it doesn't need to remember any of the information from the connection. Since it's maintaining the connection with the client, it's storing some actual stateful information. So if it's behind some kind of a load balancer and a client first connects to the first one, and then the second time they try to communicate, they communicate with the second one, that second one's not going to know anything about the first one, right? So it's going to fail. So I need some way of maintaining that stateful information. You have two ways you can go about this. One is sticky sessions, which is where your load balancer remembers which service you were connected to. But that's not always ideal because if your service actually fails, for whatever reason, goes down and you need to spin up a new one, you're still going to have to go through the process of reconnecting the client. This method is the preferred one, which is where you store all of that stateful information inside of your Redis cache. If you don't know what Redis is, it's essentially just like a database, but everything is in memory, so it's like super fast. So now I can have 1, 2, 3, a million SocketIO web servers, and they're all just going to store and grab all of that stateful information from the Redis cache. This io.on is going to listen to the connect event. That's one of the built-in events. So when a client connects to this socket service, they're going to first go in through here. And what this is going to do is set up whatever events you want to allow that socket to listen for. So this is the built-in disconnect one. I don't actually use it in this demo, but it was actually very useful when I implemented this at the company that I work for, because a huge chunk of this was adding authentication and authorization. And so when someone would like leave, like log out or something, the disconnect would handle all that cleanup, like get rid of the OAuth token and all this other stuff. But that's like a whole other presentation, so I'm not going to go into that. And then I set up 3 event listeners for them, which are defined in this file. The first one here we can kind of ignore. It's just for debugging. These 2 are the important ones: the join room event and the leave room event. And I'm going to talk more about that later, but you should know that they have these 2 events that they can listen to. All right, so those 2 things, the sockets function and the database function, are wrapped up in promises because they don't need to happen at the same time. They can happen concurrently. So down here at the bottom, I call both of them at the same time in this promise.all guy. And then when they both resolved, I should have a database connection and my SocketIO connection. And then I'm going to pass both of those into this final function, watch change streams, which is going to set up the change streams for us. So in this guy, yeah, go for it.
Redis adapter method, does that come with the SocketIO?
It does not.
Where's that come from?
It is a different library. It's this guy, SocketIO-Redis. Yeah.
And that will automatically store your stateful information. You don't have to store it yourself.
Yeah, that's correct. So in this Docker Compose file, you can see we added a Redis service here. So the host name is going to be Redis, and then its default port is 6379. So when we connected the adapter, that was the only 2 pieces of information we needed to provide: the host name and the port name, or the port number. Yeah.
I have a question. So the DB changes. The changes is propagated in the Redis cache, and the Redis cache connects to SocketIO.
No, so the Redis cache is only storing information about the sockets, like where the client is, so it can maintain that connection. The change stream. Can I like show you the next part, and then if you're still confused, you can ask me that again.
Okay.
Okay, good. All right, so in this watch change streams function, I have my database connection and my SocketIO server. What I'm going to do here is in my configuration file, I have an array of database names. So in this case, just to keep it simple, I only added 1 database name, that app. And what this guy does is it loops over that array and sets up the change stream connection for each database. So I take my database connection, I connect to that database, and then this is the magic function right here, the .watch. That's the thing that starts the change streams. The first thing you can pass into this is an array of like options that like enhance the functionality of it. So for instance, you can add a filter to it so that you're only like grabbing certain pieces of information out of the database. You can add projections so that you're only grabbing certain fields that you want. You can add whatever fields you want. So that's what that array is for. I don't use it, so it's just empty. And then the second thing you pass on to it is a object that has like your configuration options for the watch. To me, I found the most useful one was this full document. By default, when you get a change stream object, you're only going to get the delta. You're going to get what changed to the document. If you want the actual full document in there, you need to switch this to update lookup. All right. So then once the watch is set up, then we start this event listener on change. So anytime something changes in the database, we're going to get a change. And yeah, so the first thing I do, yeah.
Are there more specific events? So like instead of this logic, if operation type, update if operation type, insert, create, are there more specific events you can listen for? No, just
No.
that one single
Yeah.
change event. Okay.
Right. So you don't have to go about it this way. This is the way we ended up doing it. We were more interested in whether it was just an update or insert. We kind of ignored it if it was like deletes and stuff. So that's all this thing is doing, is it's determining what was the operation that occurred. If it was an update, then I'm only going to grab the updated fields. Otherwise, I'm going to try to grab the full document. So this part is super important. There's multiple ways you can go about it, but the way we decided to do it is, imagine you have a client that has a bunch of data on a page, and that data is, maybe you have like one section that's just kind of like arbitrary metadata, but then you have another section that's like a chat, which is just like a rolling, series of events. You're going to want to store that differently, and more than probably in two different collections. So we want to be able to listen to things across collections that might be related to the same like set of data that a user is going to be looking at. So we attach a UUID to all of those pieces of data. So if something changed in the chat or if it's changed in the metadata, I know that it's part of this one view because I have this UUID attached to it. All right. So I'm going to grab the UUID from the document that was changed. If it doesn't exist, I'm just going to return it. It's possible that it was like a delete operation or something. This second check is just making sure that it's a binary UUID. We're storing binary UUIDs, not the strings. Obviously, binaries are way more efficient. And then this last part is checking that the subtype is 4. The 4 subtype is the new standard UUID. If you've had the pain of working with Java or C#, then you know that they encode their UIDs using different endianness, and it is kind of a nightmare to decode those back out. I do work at a Java shop and we had to do that. I'm not going to show you that code because I'm afraid your eyes will start bleeding. But yeah, just keep in mind, like if you're working with Java or C#, you'll have to check for subtype 3. In this case, I'm just using like the standard UUID, so I can leave it to subtype 4. Then finally, I'm going to use this library, MUUID, which is actually this guy, UUID MongoDB. And what that's going to do is it's going to take my binary UUID, and then I'm going to convert it to a string so I have the original string. So I'm using the string version of UUID as my room name. Okay, I think I kind of skipped something here. In Socket, yeah.
So are those UUIDs the BSON document ID, or do you have your own UUID that's separate?
Own UUID, yeah. Although it's like Mongo supports like the binary UUID format, but it's not like the object ID, if that's what you're asking.
Yeah, the object ID is a form of UUID.
Yeah, but it has like that additional information, like the date and all that stuff stored in it. Yeah. Oh right, so SocketIO has this concept of namespaces and rooms. So you can connect to a namespace, and then within that namespace, you can connect to rooms. So if 5 clients connected to one room, and you want to emit information to all 5 of those people, you can emit it to everybody who's connected to that room. So when I get to the front end part, you're going to see that all my clients are going to connect to rooms based off of this UUID string. And then when a data change occurs that is related to that UUID, it's going to emit out to everybody that's connected to that room. So that's what this guy's doing. IO, the to function is saying like send it to everybody that's in this room, and then the emit is going to emit an event, and we use the collection name as the event. So that's what this guy's doing. Call this short for collection. And then this thing right here is the actual change object itself. That's it for this part. Any questions so far? Yeah.
Yeah, I've actually got two questions. First one, I'm not very familiar with replica sets. Is
Right.
that pretty much the same thing as a clustered environment, or is that something a little bit different?
So a cluster just means that you have like several nodes kind of doing the same thing. A Mongo replica set specifically means that you have one primary node, which is handling your writes and oftentimes your reads, although you can change your read preference. That's on a use case basis. And the main point of the replica set is for like redundancy and also as like a fail-safe. So if you have like 3 nodes, 1 primary, 2 secondaries, and your primary dies for whatever reason, then those 2 secondaries have an election and decide who the new primary is, and then you just keep rolling along like nothing happened. So there's no downtime.
Okay.
The other thing in Mongo is a sharded cluster, and that's like if you have a 3-node sharded cluster, instead of it being redundant, like copies of everything, you're actually splitting up your one piece of information across the 3 of them, and that does that's for like performance, so you can like speed up your writes.
So the replica set has, for example, 3 nodes all with the same data?
Yeah,
Correct?
exactly.
So if one fails, the redundancy, okay, keeps your data same.
Right, right. And I believe the reason why you need a replica set or a sharded cluster to enable change streams is because there's this thing in Mongo called the op log or the operations log, and it uses the operations log to essentially like copy things amongst the nodes, and the change streams is like listening to that op log for you. So I've heard in the past that people try to like hack and like connect directly to the op log, but that's like kind of dangerous because you can seriously screw up your Mongo database. And so they added this feature for people who wanted that. Cool. So in order to test out changes to the database, we need a simple backend. This is going to be the shortest part of this talk. This is just a really simple Express.js app that has a single route for updating a document. It connects to the database, same as the other one, and then it's setting up an Express.js app here. I don't need to go over that. The important part is this one route. It's a post route to the path update. It's going to grab that UID, or if it doesn't exist, it's going to create one for you. It's going to grab whatever arbitrary data you're trying to store, and then it's going to take our DB connection, connect to the database, connect to this collection, I just called it test, and then run update 1 with upsert enabled, which means that like if it doesn't exist, it'll create it. And yeah, it's going to try to match on the UID, and it's going to set the data. Any questions on that part? Okay. So the final piece of the puzzle is the front end. I'm going to show you how this works first, though. Hopefully, it hasn't broken yet. So I have 2 tabs open here to the front end. Let's just refresh for safety. All right, this first form, with the connect thing, is going to connect to a room based on the UID. So I generated a random UID, and I'm going to connect to it here. Now, in this second one, I'm going to connect to the same room. So now, when I create a document, maybe update, I don't remember, with that UID, and then I'm just going to type in some random data here and click update, I see that I received a change stream from the socket here. So I did indeed create it because here it generated that random Mongo object ID with it. Here's the UID attached, and then here's the data. And then you can see in the first tab, it also received the same change stream. If I ran this again, you wouldn't actually get anything. That's just still the same change stream before because there was no update operation. But now if I change some of this to something else, you can see it's got the new something else here, and this one also received it as well. Now, no matter what, that UUID is always going to be attached, and that is because I did that in the SocketIO web server right here. So every time you would send back data, I would always attach the UUID in case the client was actually listening to several different rooms at the same time. Then when I got that event, I would know which UUID this data was related to. This was actually kind of weird to write because I haven't like seen normal HTML in the longest time. I worked way too much with Angular and React. But yeah, here it is, plain old HTML. We've got just two simple functions going on, connect and update. Update is just grabbing those values from the form. It is connecting to the backend server, which is running on port 8082. We're going to go to that update path. We do a fetch to that URL, post, JSON, here's the data, simple stuff. And then finally, this connect function, what it's doing is the first time it's run, it just checks to see if you had made a connection before. I just attached it to the window. So if I've already made a connection, then it doesn't try to do it again. The WebSocket service is running on port 8083. Then here it grabs the values from the form. For the sake of simplicity in this demo, I have it so that it's only listening to one room at a time. So if it's already listening to a room, which is indicated by the UUID being attached to the window, it goes ahead and runs that leave room event so that like it gets rid of the room. Attaches the UUID to the window, and then it emits a join room event so that it'll actually join you to that room. And then finally, once you're listening to the room, you actually have to listen to events. And so the one event I'm listening to is test, because remember, my event names are exactly the same as my collection names. That's how I know where the data changes are coming from. And then all I was doing here was stringifying the data and then adding it to some pre-element that was on the page, which was this guy down here. Yeah. I think that's it. Any new questions? Yeah.
So, is there any security concerns if you have a direct connection to your DB with SocketIO, you think? And my other question is, have you ever thought of HTTP2, where supposedly with server push, it's supposed to push changes automatically to the browser?
You're talking about like push notifications?
It's called server push. It's a new thing implemented in HTTP2. I'm just curious about it.
I'm not actually familiar with that one. But in terms of the security aspect, yeah, there was definitely like a big concern. I could talk another 2 hours about what we did to add security to it. In a nutshell, basically what we were doing is a user would authenticate themselves with a separate OAuth service that would give them an OAuth token that was stored as an HTTP-only cookie. That cookie was then available to the SocketIO web service. And then we would check, inside the cluster with an OAuth backend and see what that person was authorized to watch and listen to. And then after doing that, we would actually reuse the Redis cache and store that token with an expiration so that we didn't constantly have to be pinging the OAuth service for that authentication authorization information.
Okay, so you kind of extract that instead of direct SocketIO connection to the database.
Yeah.
Okay.
How long do you set your expiration on that?
It was whatever was set originally on the OAuth token. Yeah.
What is the practical reason for having each replica having its own individual, Mongo ID, and then having a shared UUID? Why not just have the same ID across all three instead of a UUID? If that makes sense.
Yeah, no, totally. Yeah, you could just use the binary UID as like your main ID.
Yeah.
Right?
Is there a practical reason you wouldn't want to?
So the ID itself has like some extra information stored in it. It's like slightly longer in size as well. I don't really think it'd make that big of a difference.
Okay. And I have another question. I really like the font that you used in the heading of your slides. Could you tell me what that is?
This guy?
Yeah.
I have no idea. Avenir.
Thank you.
That's my information. Email, LinkedIn. This is also a blog, which I'm going to post on the Meetup chat. I'll post links to this repository along with the Medium blog that I wrote about this and just sent out today. In case you want to go through it again and torture yourself. Please subscribe to the blog at least. I do blog quite regularly.
I've got a question sort of about the architecture as well. How does this compare to using like a real-time database like Firebase to do something very similar? Do you all compare and contrast these two solutions, or was that not really something you looked into as well?
Yeah, no. We wanted to like have like our own managed solution for this, so we'd have more control over it. And I'm not like too familiar with Firebase actually. Another option that we had looked at originally was using Kafka. That has it's more complicated. It takes longer to get up and going. So we actually abandoned that initially, but we have started back up on that in the past month because we have a much better use case for it. Because essentially with this architecture, you have like a source of truth, but you don't have like a series of events where you could like recreate what happened, where Kafka like enables that event sourcing. Cool.
Thank you, everybody, for coming out, and thank you very much, Eric, for speaking. I'll have this archived up to YouTube, and unfortunately I wasn't able to get the screen share part of it, but I did point the camera at the screen, so hopefully everything should be visible. I'll put the link to the video in the meetup description when we have that all set up. And without any further ado, that was tonight's meetup. We'll have a next month's is not going to be on the third Thursday, but I think the fourth Thursday. Michael, you might be able to confirm that.
What's up?
The next meetup is being delayed because, or changed the day because of Develop Denver.
It's 8/22 is the next meetup.
All right. So the fourth Thursday. If you subscribe to the meetup, you'll get the announcement when we put that out.
Now everyone is for the third Thursday of the month, so apologize.
We have the space for about half an hour or so. So if you want, you can hang out and chat. And with that, we're officially done here.
Take all the pizza you want.